Crocodiles right here in New Jersey.
Experts are able to look at an environment today and figure out what happened in the distant past.
It's sort of like CSI. A good sediment geologist is a very sophisticated detective. They have a lot of tools at their disposal, from microscopes to mass spectrometers, and they can find a lot about a sedimentary environment by using those tools appropriately.
If we watch waves today on a beach, or if we watch a river flowing down a valley, we can see the processes operating there, and we can see that they leave a signature in the sediments that allow us to fingerprint an environment. This sediment here is ancient, but it's unconsolidated, unlithified, as we say. It could also be the case that groundwater going through this sediment could precipitate out minerals between the grains, cement them together, and this could become a sandstone. That sandstone could be thrust up into a mountain range, and still, it would have the fingerprints of its deposition, and we would be able to go up into that mountain range and say, oh, shallow marine deposit near a coast. The present is the key to the past.
And just as understanding an animal's environment leads to deductions about its life, analysis of a creature's bones can tell us about its environment.
When we look at specific details of the chemical composition of their bones and the specific isotopes of certain elements like oxygen, carbon that are trapped in their bones, they tell us a tremendous amount about what they ate and what the climate was like. And so there's lots of ways you can now narrow down a lot of older ideas about animals and say, okay, these things are now reasonable, these things we've ruled out.
Yesterday's ideas about dinosaurs are constantly changing based on new environmental work. For example, the profile of Spinosaurus, a 7-ton megacarnivore from the Cretaceous period in Africa, has recently been revised.
You might have seen portrayals of Spinosaurus as being this